All right, physicists, we're going to regroup and go through this together. This should be a fairly straightforward problem at this point. Okay, we've done problems like this at least 2 or 3 other times. And the thing that I need you to know about physics is that it's a class where I'm going to lead you through a lot of things and show you how to do it, but it's not going to be something where we're going to do it 7 or 8 or 9 times. You have to take responsibility for your learning. You need to make sure that you are learning it when we're doing it, and if not, ask for help, okay? I do want to go through this problem to make sure you're feeling good about it, but I'm just saying that it should not be the first time you're processing something like this. So the question asks, or the task asks you to determine the speed of the bowling ball traveling down the alley. Here is the graph. What are you going to do first? Draw a line? Yeah. Any line, or what kind of line? A best fit line. How does one draw a best fit line?
You can kind of like half on one side, half on the other, and just draw a line.
Yeah, you got to kind of balance it out, right? So you're going to take your ruler. If you don't have a ruler, you can use the side of a piece of paper. You can use the side of a calculator. Anything that's a straight line, it's all good. But you need to have some sort of line, that balances all of those points. Does that line need to go through the origin? No. Indeed, it does not. If it does, that's cool. If it doesn't, that's okay too. Now what? What? I heard somebody say something. Raise your hand. Yeah, go.
Find the slope of the line.
Find the slope of the line. How am I going to find the slope of the line? More fun. Help me out. How do I do it? I've talked to you guys already. Share the fun. Don't rely on the loud people. Don't rely on the loud people. How am I going to do that, friends? Yeah. You got it. Yep. It was kind of hard to see the grid lines on this, and I apologize for that. I'll tell you that when I did mine on this piece of paper, I got 3-2 as one of my points and 8-5 as one of my points. If you didn't get those points, that's okay. But I'd like you right now. Did you guys all already find your slope? Yeah? Fantastic. What did we get for values of your slope? We get numbers. We're gonna let me ask this question. Does everybody feel like they calculated that? Or do you need another second? One more moment. So I'm gonna ask every table what they got for a slope. Yeah, do you need another moment or no? You ready to go?
Yeah.
One more moment. Okay, go. All right. I would love to have your slope stated when you tell me in decimal form, not fractional form. It's just the way that physicists work with data. All right. So let's start at the back. AJ, what'd you guys get?
We got 0.66 meters per second.
So I'm gonna say 0.67 meters per second. Thank you very much for saying the units right with that slope, because that's exactly what we need. I know I do. I see that right now. Bam. There you go. Okay. So thank you for doing that. I appreciate it. All right, back table, what'd you guys get? 0.71 meters per second. Awesome. Back corner. It's okay. 0.67? 0.67. Yeah? Now, friends, I want to make sure, sometimes when we do this, we just get into this little complacent, like, oh, well, if everybody else got that, I got that too. I don't want you to do that. I want you to make sure you're being honest with yourself, because if you're not getting what everybody else is getting, does it have to be exactly the same? No. It does not have to be exactly the same. But if it's really not the same, then we need to figure out why. Because you will absolutely have the opportunity to do this by yourself very shortly, and you will be assessed on it. So I want to make sure that you understand it. This is your opportunity to ask and advocate and get help. Go. 0.75. 0.75. What you guys get?
0.67.
0.6. Did you use different points, or did you use the same points that I had? Okay, cool. Yep, and that's what I got when I did it too. But yeah, it just kind of depends on which points you use. And then I need a
We have 0.6.
0.6 as well? Okay. Fantastic. So I've got everybody, yeah? Did I get you guys? No, I can't remember. What'd you guys get? 0.67. All right. My little list is running out of space. There you go. All right. So the reason that I wanted to do this, number one, is to see where everybody was at. Also, I will tell you that in other classes, I got people that told me an answer of 1.5 meters per second. Why would they maybe have gotten 1.5 as an answer?
They did the wrong formula.
Tell me more.
Like they messed up the y minus 2 and y2 minus y1 x2 minus x1.
Yes. What did they do? They did change in x over change in y. Are you with me there? Yeah. When you're finding slope, you absolutely need to remember that it's y minus x. I wanted to point that out because I want you to make sure that you're paying attention. And if that happened to you, it's okay. We're learning together, right? So that's the answer. That's the speed of the bowling ball traveling down the alley, about 0.67, about 0.6, wherever it is. As long as you show me your work with your points, it's all good, okay? What I'd like you to do now is the follow-up question. Here it is right here. If the speed stays constant, predict, and by predict I really mean calculate, and by calculate I really mean do the problem following the guess method to tell me the position of the ball at 15 seconds, okay? Go ahead and use your speed and make that calculation. Write it out, friends. Go ahead and do that. I'm going to give you a moment to work on that together. Absolutely work with each other. That's totally fine. So you're trying to find the displacement. So again, I would like for you not to just get this estimate in your head. I would like for you to actually do the problem. What givens do you have? You know the time. So you say time is equal to, oops, not 0.15, just straight up 15 seconds. What else do you know? You also know the velocity. And your velocity may be different depending on which velocity you found. I'm going to go ahead and use my 0.6 because that's what I found. But so your answer might be a little different if you use a different speed. That's okay. Those are my givens. What's my unknown? The distance, or we're going to be fancy pants and call it the what? The displacement, the change in position. Yeah. We've got an equation that uses those three things. What is it? Velocity is displacement over time? Indeed. Just a friendly reminder that we need to get into the habit of doing the algebra. This equation is pretty easy. I think you've probably gotten that at this point. But know that next week we're going to make it harder, because that's what we do. So I want to make sure that you know how to do this so that when the equations get longer, you're okay with it. What am I going to do? Hello, friends. Come on in. Grab a seat. What am I looking for? Change in position? Is change in position all by itself already or no? It's. I do have to multiply by t on both sides. Thank you. T's are going to go away. So I've got 15 seconds times 0.6 meters per second, or it might be 0.67 depending on what you did. And you get an answer like 9. If you have, it depends on the value you have. But yeah, 9 or 10-ish. Okay. How are we doing? We good? Fantastic. All right. We are going to do a lab today. It was a lab that we were going to start on Friday. Some of you were like, we didn't get to start the lab. We're going to start it today. It'll be fine. Okay. Let me tell you the plan. In just a moment, we'll break you up into some groups. All right. So, friends, take a look up here. We've got these cute little carts. They are really like probably the cutest piece of equipment that we're going to have all year. So enjoy. I mean, they're pretty adorable. Okay. So they've got little stickers on them, all this kind of cute stuff. They've got a little switch over here, and when you flip the switch, then they light up and they run, and it's pretty fantastic, right? So these are going to be our primary equipment for this lab. Okay. A couple of things that you need to know about them. The carts should, or the buggies, that's what we're going to call them, the buggies are only to run on the floor. Please do not run them on the table, okay? We are not yet studying projectile motion. When we get there, and we'll do a bunch of labs, but we won't use things that when falling could break and then I'd have to replace. You with me? Okay? So these run only on the floor. Okay? Second piece of advice, information, whatever, you're going to collect some data for some time and you're going to mark it and you'll see what's going to happen. But the thing that I need to let you know is that the buggies do not automatically turn off. And that might seem very obvious, but often when I have bright students, they turn them on and then they're collecting the data and then they go start measuring things. And the buggy will just keep going. And we don't need that. So make sure that somebody's paying attention to stop the buggy so that we can, it doesn't go on forever. Okay? As a group, as a lab group, I'm going to ask you to do question 1 and then go ahead and start your setup. It does say here, and you'll pick this up in just a minute, to place a piece of tape on the floor. There's a lot of tape already on the floor, so you don't probably need more tape. If you don't find a piece of tape, then let me know and we'll get you a piece, okay? You're gonna use a stopwatch and then some little washers to make this happen, okay? One thing that I wanna point out to you right now, so that I don't have to interrupt, well, I probably will later anyway, is that you only need to collect data from one good trial. I will tell you that probably the first trial will not be a good trial. I've been doing this for a lot of years, and I've never seen a good trial as a first. Now, no, I don't mean that as a challenge. I mean that as it's okay if it takes you a few. But you need to have one good trial, and then you're going to do some measurement. I'm going to give you about 15 or 20 minutes to work on this, okay? And make sure that you've collected data, and then we will work on the back, but you don't need to worry about the back until I tell you to, okay? We're going to count off by 12s, all right? So hold on just a moment. So for the remainder of the class time today, you have an opportunity to show me what you know as it relates to data processing and as it relates to understanding and interpreting a graph, okay? So what I want you to do right now, we're going to look at a seating chart, and you're going to say, what? So some of you are spatial, some of you are not. I'm going to show you what it looks like. It looks like this. So this is a map of the classroom. My door is here, okay? The windows are back there. The storage room is over there, okay? So find your spot and figure out what number you are. If you need help finding your spot, let me know, okay? All you need to do is find your number. Okay. I'm 10. I think yours. 11. Yep. You're 10.
That.
Can you wait for just a sec? Okay. Thanks. Yeah, it's all symmetrical. This just seemed to be the way that made the most sense to everybody. Everybody find their number? Okay. Because I'm going to move you in just a minute, and this will tell you where you're. So you need to know your number. Does anybody need help figuring out their number? Everybody find their number?
Yep.
Okay. So now, listen carefully. Shh. In just a moment, I'm going to have you move, and while you're over in your new spot, you are going to be asked to do your data processing on the graph, as well as answer questions 5 and 6. Okay, so you are going to move to a new seat. Listen, please. The only things that you need to take with you are your Buggy Lab and data, okay? A calculator, a ruler, and a pencil. If you need to borrow a ruler, you're welcome to. Find your new spot and move there. Yeah, oops. Hold on just a second.